Section 7.5, we're graphing systems of inequalities. So we're going to look back at the steps that it takes to graph an inequality. So first thing we want to do is when we're looking at the equation of an inequality, we want to think of it as just a regular equation that we can graph. So if you replace the inequality symbol with an equal sign, you can use your calculator to plug it in and use the table then to plot points, or you can graph from any other steps that you may know how to graph a different function with. Okay, after you have plotted some points, then you need to determine if it's going to be a dashed line or a solid line to connect those points. So anytime you have a greater than or less than symbol, then you use a dashed line. If it's greater than or equal to or less than or equal to, it's going to be a solid line. And then the last step is to decide whether to shade above or below or inside or outside, depending on what the graph of the function is. So in order to determine where to shade, you want to test an ordered pair on one side of the graph. Most of the time I like to use 0, 0 because it's easy to plug into the equation. So if you plug 0, 0 into your inequality and it is a solution, it makes a true statement, then you're going to shade on that side of the graph where 0, 0 is. If it's not a solution and you get a false statement, then you're going to shade on the opposite side. So let's look at example 1. We're going to be graphing 2y minus x is greater than or equal to 4. So before I can graph this, I need to get y by itself. So first I move the x to the other side of the equation by adding x. So that's going to give me 2y is greater than or equal to x plus 4. Then I'm going to divide everything by 2. So then y is greater than or equal to 1/2 x plus 2. Now I'm ready to graph. Again, you can put this in your calculator if you want to, or you should remember the rules for graphing linear functions. This function is going to cross at positive 2, because that's the y-intercept, and then the slope is 1/2, so that means it goes up 1 over 2 each time. So I'm going to plot about 5 points for this line. Then I need to determine if it's solid or dashed. So because it's greater than or equal to, this is going to be a solid line. So I'm going to pick my test point 0, 0 and determine if I need to shade on the side with 0, 0 or on the opposite side of the graph. So I plug 0, 0 into my function. 0 is greater than or equal to 1/2 times 0 plus 2. And I want to see, is 0 greater than or equal to 2? Is this a true statement or a false statement? If it's true, I'm going to shade on the side of the graph where 0, 0 is. If it's false, I'm going to shade on the opposite side. So 0 is not greater than or equal to 2. This is a false statement, so I need to shade on the opposite side. So I'm going to shade above the line where 0, 0 is not. Okay, number 2, I have y is less than 5. So notice there's no x in this equation. So this is going to be a horizontal line through 5 on the y-axis. So that means it doesn't matter what the x value is, the y value is always 5. So I just put a bunch of points up here where the y value is 5. Okay, because this is less than, then it needs to be a dashed line because it's not equal to. And since it's less than, that would mean anything less than 5 would be included in this solution. So I would shade below the line for y less than 5. If you're not sure, you can pick a test point. So if I plugged in 0, 0, 0 is less than 5 is a true statement. So I shaded on the side of the line where 0, 0 came from. Okay, now for number 3, I've got x squared minus 5y minus 10 is less than or equal to 0. So again, I need to get y by itself first. So I move the x squared to the other side, and I have negative 5y is less than or equal to negative x squared plus 10. So now I need to divide everything by -5. Well, when you divide an inequality by a negative number, it's going to flip the inequality over. So this is going to become y is greater than or equal to 1 over 5x squared minus 2. So for this quadratic function, or for this parabola, it will probably be easier to go ahead and type this into your calculator and then go to the table and find some points. Or you can plug in values of x and just plot them one at a time. So here are the points that I'm going to use. -5, +3, -3, -0.2, 0, -2, 3, -0.2, and 5, +3. Because this is greater than or equal to, this will be a solid line. Then I'm going to pick my test point, 0, 0. So I'm going to plug 0, 0 into my inequality. And I want to see, is 0 greater than or equal to 1/5 times 0 squared minus 2? If this is a true statement, I'm going to shade inside the parabola where 0, 0 came from. If it's a false statement, I'm going to shade on the outside of the parabola. So 0 is greater than or equal to -2 is a true statement, so I'm going to shade inside the parabola. So the solutions are anything on the inside of the parabola or on the line because it's equal to. Okay, so examples 1 through 3, we were just reminding how to graph inequalities by themselves. Examples 4 and 5 are going to be systems of inequalities. So that means more than one inequality on a graph. So in example 4, we have x is greater than or equal to -1, y is greater than 0, x squared plus y is less than or equal to 5. So we're going to graph all three of these on the same coordinate plane and then see where they overlap. The intersection of all three graphs is the solution to the system. So let's start with x is greater than or equal to -1. So this is going to be a vertical line through -1, and it's going to be solid because it's equal to. And then it says greater than, so that means I would shade anything to the right of the line. So any x values greater than or equal to -1 are a solution to this system, or to this equation. The second equation, y is greater than 0, is going to be a horizontal line through 0, and this one is going to be dashed because it's not equal to, and it says greater than, so I would shade above. So right now, we need to see the double shaded portion of this graph is the solution so far in the upper right hand corner. But we've got one more function that we need to graph. So I need to take the third equation and get y by itself. So this will be y is less than or equal to -x squared plus 5. So you can put this in your calculator and go to the table and find some points to plot. I used -3, -5, or sorry, -3, -4, -2, 1, -1, 4, 0, 5, and then you can just flip those points on the other side. Okay, this is going to be a solid line because it's equal to. If I plug in my test point, 0, 0, is 0 less than or equal to -0 squared plus 5? So I want to know, is 0 less than or equal to 5? Well, that's a true statement. So that means I would shade inside the parabola where 0, 0 comes from. Okay, so now I've got 3 shaded regions here, and some of it overlaps. So sometimes it's kind of hard to tell what overlaps. So I like to go back over it and just retrace those areas. So it's kind of from the blue line up around the parabola, the green line, and then the dashed purple line on the bottom. Anything inside that region would be part of the solution. Okay, same thing for number 5. We have 3 equations that we're going to graph on the same coordinate plane. First thing, I got to get y by itself. So the first equation, I would need to move the 3x to the other side, so it's going to become positive, and then I would have to divide everything by 2. So it's going to give me y is less than 3 over 2x plus 3. Okay, so that means that this line crosses at positive 3 and has a slope of 3 over 2. So it goes up 3 over 2, up 3 over 2. And you can go down 3 and left 2 as well. This is a dashed line because it's just less than. If I plug in my test point, 0, 0, 0 is less than 3 is a true statement. So I would shade on the side where 0, 0 came from. Okay, now we're going to look at the second equation. So the second equation, I would have to move the x and divide everything by negative 4. Because I'm dividing by negative 4, I would have to flip the inequality as well. So this is now y is less than 1/4 x plus 1/2. So this equation crosses at 1/2 and goes up 1 over 4. Well, when I go up 1, I have to go from a half to another half. It would be at 1 1/2 and then over 4. So each of these points is going to fall halfway between. Okay, again, this one's going to be a dashed line because it's not equal to. If I plug in 0, 0, 0 is less than 1/2 is a true statement, so I would shade below the blue line. Now for the third equation, we're going to move the 2x to the other side. So this is going to be y is less than negative 2x plus 3. So this crosses at positive 3 and has a slope of negative 2. So it goes down 2, right 1. Down 2, right 1. And this also is going to be a dotted line. If I plug in 0, 0, 0 is less than 3 is a true statement. So I need to shade on the side of the green line where 0, 0 is. So that's to the left. So you can see the part that's triple shaded is kind of this trapezoidal shape towards the bottom. So if I retrace those dashed lines and then shade inside, anything going down would be included in the solution to this system of inequalities.